Meet John. Just like you, he is a first-year student. And like you, John also struggles with organic chemistry that it stresses him out.
But worry not, John. Chem Helper is here to help you.
The planet is ruled by carbon compounds. They can be found in practically everything we can see, touch, or smell.
But what precisely do we mean when we say hydrocarbons? We're talking about carbon and hydrogen compounds here, but tell me something. Are all carbon compounds composed only of carbon and hydrogen? Are there any other atoms in the compounds? If all of the compounds contain simply hydrogen and carbon, shouldn't they all have the same or comparable properties? Well, no, this cannot occur. Carbon compounds exhibit a wide range of characteristics due to the presence of components other than carbon and hydrogen, which brings us to the topic of functional groups. What does this all mean? The term groups refers to a collection that denotes a group of atoms, while functional implies having a significant role or function. This means that the functional group is a collection of atoms with distinct characteristics. The existence of functional groups specifies the qualities, regardless of the length of the primary carbon chain or the side chains linked to it.
There are a few functional groups for which we are well known. We must have come across terminology like alcohols, aldehydes, ketones, and others. These are all just functional groups. In any circumstance, the qualities of the created chemical will be determined by two criteria: the existence or absence of single, double, or triple covalent bonds between carbon atoms is the first aspect to consider. It indicates that the compound's saturation or unsaturation may further influence many of its reactions. The presence of a functional group is another major impacting element. This group is responsible for the compound's distinctive features. Let's have a look at some more examples of functional groups and their structures. The first group that we have here is the hydroxyl group. Alcohols or ethanols are chemical molecules that are directly linked to carbon and include the hydroxyl functional group, OH. Carbonyl carbon is this carbon that is directly related to OH. This generic formula represents alcohol, where R is an alkyl group. The amino functional group comes next, which is effectively nitrogen with two hydrogens. The amino group is called a basic functional group because if a molecule with an amino group is placed in a solution, it will get ionized as it grabs a proton from the solution and becomes an H3+, causing your solution to become more basic. These generic formulas represent each type of amino group, which is the first, second, and third amine. R here is also an alkyl group as mentioned earlier in the hydroxyl functional group.
Then we have a carbonyl and carboxyl group. The carbonyl group is composed of aldehydes and ketone. Ketone is made up of two carbon atoms that are double bonded to an oxygen atom as well as single bonded to two R groups. Acetone, a familiar chemical product such as nail polish remover, is a basic example of ketone. In contrast to ketone, an aldehyde has the general formula RCHO. A carboxyl functional group sounds like a carbonyl functional group. However, a carboxyl is a mixture of hydroxyl and carbonyl functional groups. This combination is represented by the generic formula carboxyl RCOOH, which is derived from the carbonyl functional group by converting one alkyl group to a hydroxyl group. Acetic acid is an example of a carboxyl functional group that may be found in everyday life. Here is a list of functional groups that you can learn and memorize by yourself to improve your understanding of organic chemistry.
I am so happy. Thank you, Chem Helper.